Hi students! Today we will begin our next really large unit on quadratics. And before we can begin that, we have to have some skills under our belt. So we are going to begin by learning how to simplify polynomials. There are two big ways that we're going to do this. One is by combining like terms with adding and subtracting, and the other is with multiplying. So we're going to look at these separately, and then we'll kind of put it all together as we enter into our new unit. So as we begin, there are 4 vocabulary terms we need to be familiar with. So when I say them, you know what I'm referring to. The first is the name for a single term. And we've heard of terms before. We've heard of variable terms, which might look like 5x. And we've heard of the constant terms, which are just numbers, maybe like 14, right? These are both examples of terms. The formal name for a term is called a monomial. Okay, and this indicates a single term. One term is called a monomial. When you have lots of terms together, that is actually called a polynomial. And you can tell the distinction between the monomials because they are separated by pluses and minuses. You may want to write that down. Separated by pluses and minuses. So for example, if I had a plus between this 5x and this 14, there would still be 2 terms. The 5x is one term or one monomial. The 14 is another term or another monomial. And together there are 2 monomials. So in this first example, it says to circle the monomials. Okay, remember a monomial is a single term. So 2, for example, is a monomial. X squared is a monomial. Now we haven't seen a lot of the exponents yet, but we will get into those during this semester. Now x plus x, because of that plus in the middle, this is actually 2 terms. So this is not a monomial. A monomial is just one or a single term. 3xy, this doesn't look like something we've seen this year, but this actually is a monomial. Notice there are no pluses or minuses separating the 3x or the y. So altogether, that is a product, and it's a monomial. In the next expression, negative 3x and y, they're separated by that plus, which means I have 2 monomials, but together it is not a monomial. And then the last term, the last expression, I see no pluses or minuses. So this 3x squared y squared all together is one monomial. So all of the things in a monomial, if there's multiple variables or numbers that are put together in the single monomial, they're always being multiplied together. Okay, so those are all monomials, all the ones that I've circled. So the sum or difference of 2 or more monomials or 2 or more terms, remember sum means we're adding, difference means we're subtracting. So if I string together monomials with pluses and minuses, now it's not just one term, now we have more than one term. So we call it a polynomial. And I know that you guys know a little bit about prefixes. The prefix mono means one term. The prefix poly means many. So 2 or more monomials together is many monomials, so together it'd be called a polynomial. Okay, now if my polynomial is the sum or difference of exactly 2 monomials, the prefix for 2 is bi. It's called a binomial. Prefix bi means 2. So down here we've got 4 expressions. We're trying to figure out which ones are considered binomials or which ones have 2 terms in them. Remember, terms are separated by pluses and minuses, right? All right, so in the first term, x plus y, I see 1 plus and it separates the x and the y. The x by itself is a monomial, the y by itself is a monomial, but together, because they have a plus between them, it is a binomial. The second expression, xy plus z, xy is a monomial, z is a monomial. There's a plus that connects them, so that is also a binomial. There are two monomials. The next term the next expression has no pluses or minuses. So this is considered one term. The 2 times the x squared times the y, it's all being multiplied together. It is a monomial, not a binomial. And then in the last expression, 2x squared is one of the monomials, y squared is the other monomial, and then the minus separates them, so there are 1, 2 monomials, so this is also a binomial. Let's keep going. You may be starting to see a pattern, but the sum or difference of exactly 3 monomials begins with the prefix for 3, which is tri. It is called a trinomial. So if you see 3 terms or 3 monomials that are separated by pluses or minuses, remember pluses or minuses, it's called a trinomial. Tri for 3. So in this example, we're going to circle all the trinomials. We also have 4 expressions. So remember, each of these is called an expression. We're trying to name the type of expression is. Okay? So in the first expression, I have 1, 2, 3 monomials, which means the whole thing is a trinomial. The second expression, 3x, y, z, those are all being multiplied together. This is considered one monomial. It is not a trinomial. Now, it does have 3 different variables, but they're together as a monomial. The third expression, I have 1, 2, 3 monomials. So together, this expression is a trinomial. And then in the last one, once again, I have no pluses or minuses. It's just a bunch of variables being multiplied together, so that is considered a monomial. All of these expressions are called polynomials, but the 3 distinct kinds we're looking at are monomial 1 term, binomial 2 terms, trinomial 3 terms. So now that we've got the vocabulary down, now we're going to try to simplify some of these polynomial expressions. I said there were going to be 2 big parts we're going to focus on. The first one would just be to combine like terms by adding or subtracting. Okay, so let's first remember what like terms are, because we have talked about this year. Like terms, they have to have the same variable. And something we haven't talked about really yet, same variable or variables, since some of our terms will have more than one variable. But one thing we haven't specified yet is that these variables have to have the same exponent. And I'll explain what that means. We haven't really seen exponents yet this year. Okay, so let me just, I'm going to go back to something we've done before. So for example, if we had 2x plus 5x, this looks like something maybe we've combined while we were solving an equation. Together, this is a binomial, okay? 2x is one monomial, 5x is the other. Now, these are like terms because they have the same variable, so when we would add them together, we would add their coefficients together, and we would get 7x, right? Well, now, our expressions, they may look like that, but there may be a little bit more to them. Now, maybe one of our variables has an exponent of 2. So now my 2x and my 5x squared, even though they both have the same variable, their variable does not have the same exponent. So what's an exponent? The exponent is this little number up here. So this x has an exponent of 2. The other x, we can't see it, but there's an understood 1 right there. It has an exponent of 1. So because these exponents are not the same, this 2x and this 5x squared are not like terms. So we cannot combine them. We would just leave it like that. Okay, so let's look at how this might look. So first of all, let's look at number 4. We see parentheses. Now, if you ever have parentheses around expressions and there's no number in front, so like there's nothing here or here that we need to multiply by, then the parentheses aren't really necessary. So we can just take them out, or we can kind of ignore them. Okay, I'm gonna actually, let's see if I can do this. I'm gonna just kind of make them go away. So you can just kind of erase those on your paper. Okay. So we don't need those parentheses, but let's look at our terms. Altogether, we have 6 terms. 1, 2, 3, 4, 5, 6. Now, I want you to also remember that the sign in front of the term goes with the term. So, let's look and see if we have any terms that are like. So, for example, the 2x squared, it has an x variable with an exponent of 2. Let's see if we have any other terms that have an x exponent with a variable, with an exponent, an x variable with an exponent of 2. I also see this 1x squared here. Now notice I'm circling the plus in front of it so that I know that that's a positive one. Those two terms are like, so I can put those together. And remember, when we combine like terms, we are just adding the exponents. So the 2 and the 1 get added to make 3, and then I just have 3x squared. So 2x squared plus 1x squared is 3x squared. Okay? Let's see if we have any other like terms. All right, I have my next term is a positive 3x. So I'm looking for another variable term that has an x with that exponent of 1, that or doesn't appear to have an exponent. And that would be this negative 5x. They both have an invisible 1 exponent. So they're like terms. I've got a positive 3 and a negative 5. So we're going to add those together because they're different signs. We subtract and take the sign of the larger number. So 3 and a negative 5 is negative 2. Up. So negative 2x. And I could put the 1 for my exponent or leave it off. It's understood 1. All right, and then let's see if we have any other terms. The terms that we have left are this positive 2, which is just a constant, and this negative 5, which is just a constant. Constants are always like, especially if they don't have variables, so we can combine those to make negative 3. So this 3x squared minus 2x minus 3 is the simplified version of that 6-term polynomial. Okay? Let's look at example 5. Now, example 5, let's look at the parentheses and see if they're necessary. In front of the first set of parentheses, there is no number that I need to multiply by that parentheses. So I'm going to just get rid of that first set of parentheses. But in the second set of parentheses, I want you to notice that there is a negative in front. This is very, very important. I want you to put a star next to this example. If there's a negative in front of your parentheses, that's like a negative 1, and you have to distribute it. Because what you're doing is you're not just subtracting that first term, you're subtracting all 3 of those terms in that parentheses. So you have to distribute the negative to all of them. So let's do that first, and then we'll see if we have any like terms. So I'm just going to rewrite the first polynomial, 2x squared plus x minus 4. Now let's distribute the negative 1. Remember, you're just multiplying. When you multiply by a negative, you're just changing the sign of the term. So negative 1 times x squared is negative x squared. Negative 1 times negative 4x is positive 4x. And negative 1 times positive 1 is negative 1. All right, now let's see if we have any like terms. Our first term is 2x squared. Let's see if we have any other x squared terms. We do. We've got this negative 1x squared. So we can combine those. A 2x squared and a minus 1x squared is just going to be a 1x squared. Remember, you don't have to put a 1 coefficient, just like you don't have to put a 1 exponent. You certainly can, though. It's not wrong. All right, let me get another color. Okay, let's look at our next term. We have a plus x, so we're going to look for another just x term, and I see a plus 4x. Now remember, in that x term, it's like a 1x. So 1x plus 4x is going to be plus 5x. And then our last two terms, we've got our constants, -4 and -1. Since they're both negative, they'll combine to make -5. So here's the simplified version of that expression. All right, here are two more. If you're getting the hang of it and want to give these a try, just pause the video and try them on your own. Otherwise, keep it going and we'll talk about it together. In number 6, we've got this first expression in the first set of parentheses and the second in the second set of parentheses. Notice that there is a plus between the parentheses. So I'm not distributing a negative. There's no number in front of the parentheses, so I don't need these parentheses. I can just erase the parentheses. Okay. All right, now we're going to see if we've got any like terms. So I always start with the first term, 3a squared. Do we have any other a squared terms? And it doesn't look like I do, so I'm just going to rewrite that term. All right. Let's keep going. My next term is positive 3ab. So this is our first time of seeing a monomial that has two variables. So we can only combine it with another term that also has a and b to those exponents of 1. They both have an exponent of 1, right? And I see that I also have a positive 4ab. So those two can combine. Remember, I'm going to add their coefficients together. So 3 plus 4 is 7ab. Okay. And then let's see what we've got next. We've got a negative b squared. That's like a negative 1b squared. I do have another b squared term. It's positive 6b squared. So if I combine a negative 1 with a positive 6, that will be a positive 5b squared. And that's a simplified version of that. All right, next example. Look at your parentheses, see if you need them. The first set of parentheses we do not need. The second set of parentheses, there is a negative in front. So that -1 we're going to have to distribute to the other terms inside the parentheses. So let's do that first and then we'll look at which terms are like. So we'll rewrite our first polynomial, 5y squared plus 7y plus 8. -1 times 2y squared is -2y squared. -1 times -4y is positive 4y. -1 times positive 3 is -3. All right, so now that we have gotten rid of our parentheses, now we can begin combining like terms. Our first term is 5y squared, so we're looking for another y squared term, and I see -2y squared. When I combine the 5 with the -2, that makes a 3y squared. Remember, we're just adding the coefficients together, the numbers in front. You're not doing anything with the exponents. Okay, next term is positive 7y. So I'm looking for another y term, and I see a positive 4y. Those are going to combine, the 7 and the 4 combine to make positive 11y. All right, my last terms are constants, positive 8 and -3. Those are going to combine to make a positive 5. Hopefully you're kind of getting the hang of this. So example 8 is an application question. It says the measures of two sides of a triangle are given, and they're given as these crazy looking expressions. P is the perimeter. Find the measure of the third side. So we're trying to figure out how long that side of the triangle is. Now we do have an expression over here for the perimeter. Remember what perimeter means. Perimeter is what you get when you add all of the sides of a shape together. So if I added all three of those, it's going to equal over here where it says P. But what I need to do is find the third side. So if I knew that all of the sides added up to this expression on the left, and I subtracted the two sides that I knew, then I would be left with the length of the third side, right? So what we really need to do is we need to add these two guys up, see what it is, and then subtract it from the total perimeter. So if I look at those two sides that I know, if I combine the like terms, I'm going to combine 2x squared with this 1x squared to make 3x squared. Then we'll combine the 3x with the 3x, which will just make 6x. And then we'll combine the two constants, the 6 and the -5 will make a positive 1. So this is how much those two sides are together. If I subtract that from the perimeter, then that will give me the third side. So I'm subtracting 3x squared plus 6x plus 1. Now notice I put the whole thing that I'm subtracting in parentheses. And the reason why is that's going to help me remember that that negative in front, that minus, means that I'm actually subtracting every term, or I can think of it as multiplying every term by a negative 1. So let's go ahead and do that first, and then we'll have the length of the third side. So first of all, my perimeter is 4x squared plus 5x plus 5. So I've got this negative 1. I've got to distribute. Negative 1 times 3x squared is negative 3x squared. Negative 1 times 6x is negative 6x. And negative 1 times 1 is negative 1. Now let's see if we have any like terms. 4x squared will combine with the negative 3x squared. Remember, we're just combining the 4 and the negative 3 in front, which will make 1x squared, and I don't need to write the 1. I can just put x squared. All right, then we have our next terms. We've got a positive 5x and a negative 6x. When I combine a positive 5 with the negative 6, I get negative 1. I don't have to put the 1. I just need to make sure to put the negative. So negative x. And then lastly, we'll combine those two constants, which are positive 5 and negative 1, and those are going to combine to make positive 4. So as weird as this expression looks, that length represents the length of this third side of our triangle. Here's some more application questions, and the reason we're showing you these is because these are the types of questions you may see on your TSI or on your PSAT or SAT, so you do need to be familiar with this. So number 9 says find the area of the shaded region, that's the light gray part of the rectangle, if 9x squared minus 6xy plus 3y squared is the area of the total region. So the entire rectangle has this area, and then this 3x squared plus y squared is the area of this little part, okay? So if we take out that little part from the whole region, the shaded part will be what's left, which is what we're trying to find the area of. So we're going to start with the whole region, which is the 9x squared minus 6xy plus 3y squared. And we're going to subtract the little white region, which is 3x squared plus y squared. Now notice that I put that whole little region in parentheses because I need to subtract the entire part. So that negative in front, that negative 1, we're going to have to distribute. Don't forget that little piece. It's very important. And that'll get you if you don't pay attention. So let's do that first. So I'm just going to rewrite the first part, the total area. Now let's distribute that negative 1. Negative 1 times 3x squared is negative 3x squared. Negative 1 times y squared is negative y squared. All right, we've got to be very careful here because we have a couple different variables going on. Make sure you're combining the right terms. Our first term is 9x squared. My other x squared term is negative 3x squared. So if I combine the 9 and the negative 3, we'll get a 6x squared. All right, my next term is the negative 6xy. So I've got an x and a y, both raised to the first power, and I don't have any other terms like that. So I'm just going to rewrite it. It doesn't combine with anything. And then my last two terms, we've got positive 3y squared. I do have another y squared term, and that's this negative 1y squared. So if I combine the 3 and the negative 1 there, we'll get positive 2y squared. So this expression, which is a trinomial because there's 3 terms, and you can see because they're different colors, represents the area of the shaded part of this rectangle. Number 10 says find the total area of the figure. Total always indicates just adding everything together, right? So we're adding this expression with the 4y squareds, okay? So we can just go through and see which terms are like. Let's start with the 13x squared. I don't have any other just x squared terms, so we'll just rewrite that guy. Then I've got a positive xy. I don't have any other terms either that have an x and a y, so I'll just rewrite the xy. And then I've got the y squared here, but then I've got 4 other y squareds. So altogether I've got 5 1y squareds. Or you could think of them all as having a 1 in front. If you add the 5 1s together, you'll get 5. So plus 5y squared. And that is simplified. That represents the total area of the region. Here's another one. Find the area of the shaded region if the area of the total region is this. Okay, so the total region is the entire rectangle, but we just want the area of the shaded part, so we need to subtract out these 2 little white rectangles, okay? So we're going to start with everything, which is 5x squared minus 4xy plus 2, and then we're going to take away the xy, and we're also going to take away the x squared. So we're going to take them both away. Let's see if any of these terms are like. Let's try to simplify now. Our first term is an x squared term, and I do have another x squared term over here. I've got this negative 1x squared. So 5 and a negative 1 combine to make 4x squared. All right, my next term is negative 4xy. I do have another xy term, and that's this negative 1xy. When I combine a negative 4 with a negative 1, I get negative 5xy. And then I'm left with that little o2 at the end, so we'll just put him down. He doesn't have a like term. So this expression represents the area of just the shaded part. So I know these expressions are kind of weird looking, but hopefully you can start to get used to them.